Hi everyone, my name is Arush Vishwakarma and this is my teammate Vikram Rao here. Our presentation is titled Who's at Fault? A car accident investigation at the intersection of Ballarat Road and Hurley Court in Footscray. We used physics concepts like kinematics, force, energy and momentum to analyze the accident and find which driver was responsible. The crash involved between two vehicles, a Mitsubishi Outlander Aspire heading east toward the city, and an Audi A3 Sportback turning right at an intersection. There were no witnesses, clear weather, and no distractions such as alcohol, drugs, or mobile use. Both drivers blamed each other, so our task was to apply physics to determine who was truly at fault by analyzing speed, friction, and motion. Each car had one driver only. The Mitsubishi driver weighed 85 kg and the Audi driver 72 kg. So the road was dry and sunny, and we carried out a friction test using 10 kg tire block. So the Mitsubishi stopped about 10 meters from the collision point, while the Audi stopped roughly 20 meters away. These measurements were crucial in determining their speed and stopping distances. So here are our diagrams, and in the diagram the red car represents the Mitsubishi and the black car represents the Audi. So in the picture, so in the first slide there is before collision, and in the remaining two other slides there is the during collision and after collision diagrams. So this helps us visualize how the crash unfolded and provided accurate data for calculations. So here is our during collision and after collision diagrams. You can have a look at this. We measured a pulling force of 70 newtons from the dynamometer during our tire block test using the coefficient of kinetic friction mu, which is F by mg. So we got mu is which is 0.0.71. So confirming the road has excellent grip. So after the crash, since both cars were sliding rather than rolling, kinetic frictions was the main resisting force. So while doing the static friction workout, before the block began sliding, the maximum static friction force was around 80 newtons, slightly higher than kinetic friction. This shows the maximum grip point just before motion begins. After that, friction drops to the kinetic value of 0.71. So here we calculated some of the masses of the vehicle. So those are, so Mitsubishi has got the 1630 plus 85 kg of driver, which is in total like 1715 kg. So for the Audi, the car weight is like 1390 and the driver weight was 74 kg. So in total it was like 1464 kg. So combined total mass of the both car and the drivers it is which is 1379 kg. So the slide angle after collision was 24-degree north of the east and the coefficient was 0.17, which was used for post-collision motion analysis. After impact, both cars were struck together and slide 3.2 meters before coming to rest. We used this distance to find the post-collision velocity, which tells us how fast both cars were moving right after impact.
Hello, this is Vikram. I am going to cover the remaining parts. My friend already covered the previous part, so now I find the car's speed after collision. So let's consider the initial velocity of the both cars is vi and the final velocity is vf. So we use the equation of motion and the final velocity becomes the 6.68 meter per second. After the crash, we calculated the post-collision speed that is 6.68 meter per second by using the work energy principle to figure out. Solve the velocity in the two components, that is horizontal component and the vertical component. We get the like 6.10 meter per second for the horizontal component, and for vertical component we get the 2.72 meter per second. The components are used for momentum calculation. Now I am going to calculate the momentum of the car speed before collision. We use the known parameters to calculate the momentum, that is mass of the Mitsubishi and the mass of the Audi. The total mass becomes 3179 kg. The further calculation in the next slide. Now we calculated the velocity of Mitsubishi, which is 11.31 meter per second, and for the Audi, that is 5.91 meter per second. It compares that the Mitsubishi is like have higher velocity. Now we will analyze the stopping distance and the timing. The distance between the Mitsubishi and the collision point is 10 meter, and for the Audi, that is 20 meter from the collision point, and the given parameters are also included. Now we will calculate the time to collision when no brake is applied. Time for Mitsubishi to reach the collision point is 0.88 seconds, and for the Audi is 3.38 seconds. So we know like Mitsubishi had higher momentum and arrived faster. And the brake only distances is 9.19 meter for the Mitsubishi, and the braking distance is 2.51 meter for the Audi. Hence Mitsubishi could not avoid collision. Now we calculate the total stopping distance and the reaction time. For available distance for the Audi is 10 meters, so not enough to stop. Finally, we found the Mitsubishi as the guilty. Here is given applications of conservation of law and energy. Confirms the inelastic collision, car sticks together, support velocity, and this law applied for short duration, that is E kinetic energy is equals to 1 by 2 mv square. The final velocity after collision and the sliding distance is 3.2 meter after the crash. Finally, we found the Mitsubishi as a guilty. Mitsubishi has a higher momentum and arrived fast. Audi was likely already in the intersection, so the main conclusion is the Mitsubishi struck the Audi. Here is the references from where we use the photos and from the formulas from the physics classroom. At last, thank you.